Hello everyone. So today we are in the fourth class of indefinite integration theorems and standard forms and with the proofs. So we have done the first class was all about standard forms because we learned to find out the standard forms because the integration definition, it does not have a special definition, but it is also called as antiderivative. So finding integration is also called as a primitive, finding primitive value. एंड हमने उसके स्टैंडर्ड फॉर्म्स डिस्कस किए थे इन द सेकेंड क्लास वी डिस्कस्ड अबाउट few theorem one theorem of substitution and then few results related to that, and in the third part we also discussed about some again standard forms. So today we are also going to discuss some standard forms and their proofs. Remember that you will get at least one question in the exam from this series what we are discussing, so you might score 4 to 7 marks from this series, okay, as far as your final board exam is concerned. Okay, let us begin with today's class. I'll share the screen first and then we'll start with the three important standard forms that we also use in the problems that we solve. Okay, now wait a minute. This is all right. I hope you can see my screen. Okay, this was the last thing that we did last time. Cosec x का integration किया था, and now to move ahead, we are going to start with three important standard forms today. The first one of this set, okay, is integration of 1 upon x square plus a square dx. Okay, now can be solved by using two methods. One simple method, first method is very simple method. We can use this method. Suppose, let's say if I divide the whole thing, or if I take 1 upon a square common, 1 upon, if x square is common, that means this becomes x upon a whole square plus 1 dx, right? अगर नहीं समझ में आया तो थोड़े अलग अलग तरीके से मैं आपको दिखा देता हूँ. This can be written as x square upon a square. I'm taking 1 upon a square, sorry, a square common. 1 upon a square will come out, and this becomes 1 upon 1 plus x upon a का होल स्क्वायर. तो इसको देख के किसकी याद आती है? दो चीजें मैं आपको यहाँ पे, आई वॉन्ट यू टू अंडरस्टैंड टू डिफरेंट थिंग्स. नंबर वन, इंटीग्रेशन ऑफ 1 अपॉन 1 प्लस एक्स स्क्वायर अगर मैं करता हूँ dx, then that is equal to tan inverse x. If you are aware, tan inverse x या फिर minus cot inverse x. Okay, but if it is 1 upon 1 plus ax plus b, that means a linear quantity is there, then the answer remains the same, tan inverse ax plus b. But what is important is we have to divide by the coefficient of x plus c. ओके, दिस फॉर्म जो लास्ट टाइम हमने लास्ट सेकेंड क्लास में हमने सीखा था, इंटीग्रेशन ऑफ एफ ऑफ ए एक्स प्लस बी इज 1 अपॉन ए, यू हैव टू डिवाइड बाय द कोएफिशिएंट ऑफ एक्स. नाउ दिस इज 1 अपॉन ए स्क्वायर. ओके, रिमेंबर दिस इज tan inverse x upon a, correct, into, now remember we have to divide by the coefficient of x. now coefficient of x का मतलब क्या है? x के साथ जो है, x के साथ क्या है? 1 upon a है. so I have to divide by the coefficient of x, which is 1 upon a. now this is equal to 1 upon a square. It is 1 upon a, that means 1 upon a का reciprocal, that becomes a, tan inverse of x upon a plus c, and that means integration of final thing, that is equal to 1 upon a tan inverse x upon a plus c. Hence the first theorem for today, first proof for today is 1 upon x square plus a square is 1 upon a tan inverse x upon a plus c. Now this is the first proof for today. All right. Now very interesting, especially this first जो proof है इसको हम लोग अलग तरीके से भी कर सकते हैं. I just want you to become aware कि ये थोड़ा सा complicated तरीका भी हो सकता है. जो हमने अभी किया that was a very straightforward proof. But अगर आपको किसी को complications चाहिए then I'm showing you how to solve it by using a complicated way. But which is a right way. Even you can solve this, you can use this method in the exam. So here what we do, just like we have done in derivative standard substitution हमने किए थे. तो standard substitution में अगर आपको याद है तो x plus x square plus a square अगर दिखता है then the standard substitution is x is equal to a tan theta. So I'm going to do the same thing. यहाँ पे भी ऐसे ही होगा. Put x is equal to a tan theta. If I put x is equal to a tan theta dx, that is derivative of x 1 into dx हो गया. A tan theta का डेरिवेटिव sec square theta d theta, राइट. ऑल्सो यहाँ पे मैं एडिशनली अभी से करके रखता हूँ. tan theta का वैल्यू होता है x upon a because of this, and this also indicates theta is equal to tan inverse x upon a, right. This I'm going to use towards the end. Okay, now let us come back to the question once again. I is equal to, remember dx is a sec square theta d theta. dx is a sec square theta d theta. x के बदले आएगा a tan theta plus a square. Okay, now that is equal to a sec square theta divided by a square tan square theta plus a square d theta. Do not worry, ये theta बाजू में निकाला है हमने. Now that is equal to a sec square theta. If I take a square common, in the bracket it will be tan square theta plus 1 d theta. Now that is equal to a sec square theta divided by a square 1 plus tan square theta. According to the basic identity of trigonometry, it is also equal to sec square theta d theta. Coming here, I is equal to, now sec square theta gets cancelled, 1a gets cancelled. So 1 upon a, which is a constant term, I'm taking outside. Inside what remains is 1 d theta. Now because I'm taking the integration with respect to theta, 1 upon a, 1 का इंटीग्रेशन हो गया थीटा, बिकॉज वी आर टेकिंग द इंटीग्रेशन विथ रिस्पेक्ट टू थीटा प्लस सी, ये तो बनता है. हेंस आई का वैल्यू कितना बन गया, 1 अपॉन ए tan inverse x upon a plus c. So you have two choices for the first theorem, right? You have two choices for the first theorem. This is number 1 again. All right, let's move on to the next one, that is the second and third. Second समझ में आ गया तो third भी समझ में आ गया, right? Again remember few important things. Number 1 is ये series का कम से कम एक question 4 to 7 marks you are going to earn out of this series. Okay, minimum 1 question you will get in the final exam. Second, आपको सिर्फ ये वीडियो देखने के लिए नहीं, this is not a movie, this is something you are learning for yourself. So please be seated with your notebook and pen and मेरे साथ notes निकालो, अपना notebook एक बनाओ. This we are creating the series of the proof and theorems which is going to give in total आपको जैसे मैंने कहा 4 marks minimum. This series total जो है integration के बाद I'm going to start with vectors. This series is going to give you total minimum 12 to 14 marks in the final exam. Okay, now let's move on again to the next one, that is integration of 1 upon x square minus a square dx. ओके नाउ एक्स स्क्वायर माइनस ए स्क्वायर dx, बचपन से हम देखते आ रहे हैं एक्स स्क्वायर माइनस ए स्क्वायर, दिस इज ऑफ द फॉर्म पी स्क्वायर माइनस क्यू स्क्वायर. अगर पी स्क्वायर माइनस क्यू स्क्वायर अपनी जिंदगी में आता है तो वी विल राइट इट एज पी प्लस क्यू इंटू पी माइनस क्यू. इससे एक बात और याद आ गई मुझे, सम इंटरेस्टिंग एंड इम्पॉर्टेंट फैक्टर. दिस is helpful while in the competitive exam especially. Suppose you are taking 22 square minus 21 square. This is a random example. The answer is 43. How do I get this answer as 43? I'm using this principle. Remember, I'm using this principle. So सिर्फ सीखना नहीं, आपको लाइफ में अगर अप्लाई कर पाते हो तो मैथमेटिक्स इज वेरी इंटरेस्टिंग एंड वेरी इजी. Right? See why? Because 22 minus 21 will be the second bracket. 22 minus 21 will be the second bracket. That is always equal to 1. So what remains is the first bracket, 22 plus 21, which is 43. What I'm trying to explain you is when you are taking the difference between the square of two consecutive numbers, the difference between the square of two consecutive numbers, the answer is always the sum of two numbers. तो इसका मतलब सर अगर 121, if I am taking 121 square minus 120 square, I'm just again giving you a random example, so the answer is 241. You just have to add them, right? So try this, use this in your regular life. This will be helpful for you. Coming back to integration, what I'm doing is this is the first important step of this theorem or this proof. इसका जो प्रूफ है, इसका फर्स्ट इंपॉर्टेंट स्टेप है 1 upon 2a. सो आई एम डिवाइडिंग बाय 2a एंड आई एम मल्टीप्लाइंग. द ओनली थिंग इज मैंने डिवाइड बाहर किया है, मल्टीप्लाई अंदर किया है. एंड एट द सेम टाइम नीचे जो एक्स स्क्वायर माइनस ए स्क्वायर है, आई एम राइटिंग एक्स प्लस ए इंटू एक्स माइनस ए. So this step is very important. Once again you are multiplying and dividing by 2a. multiply अंदर किया, 2a बाहर माइनस डिवाइड किया है. 2a anyways is a constant term, so you can multiply and divide. So 1 upon 2a. Now the second important step of this proof is, again I'm repeating, अगर ये समझा तो third one भी आपके लिए easy है. Second important step of this proof is x plus a माइनस एक्स माइनस ए. बहुत बच्चे मुझे पूछते हैं कि सर ये नहीं समझा, दिस स्टेप दे डोंट अंडरस्टैंड. ओके, सो आई विल बी डूइंग अ रफ वर्क टू जस्ट टू एक्सप्लेन जो मैंने अभी लिखा है. सी मेरे पास अभी सिर्फ 2a है, राइट? सो if I am writing x plus a minus x minus a, let us try and solve this. x plus a minus x minus a, तो क्या हो जाएगा? इसको अगर एक्सपांशन किया है तो x plus a minus x plus a हो जाएगा. a and a gets cancelled, what remains is 2a. So I am writing 2a but in a different format. मैंने x को add किया, x को subtract किया. That's the only thing you have to understand. Okay, once this is done, this is theorem is very easy, this proof is very easy. इसको हम लोग separation करते हैं. Inside the bracket, first part is x plus a upon x plus a into x minus a dx minus यहाँ पे आएगा x minus a into x plus a into x minus a dx. Right? So we have created two parts, we have separated them. Now in the first part, you can observe in the first part, now x plus a gets cancelled. In the second part, x minus a gets cancelled, divide ho raha hai, right? So what remains is 1 upon 2a integration 1 upon x minus a dx minus 1 upon x plus a. Okay, that means I is equal to, now what this shows, now this is 1 upon a, सॉरी 1 upon x का इंटीग्रेशन जो स्टैंडर्ड फॉर्म ने हमने सीखा था, 1 upon x का इंटीग्रेशन क्या है? दैट इज log x, राइट? एंड प्लस c. एंड वेरी इंपॉर्टेंट थिंग, वन मोर थिंग यू हैव टू अंडरस्टैंड दैट अगर 1 upon ax plus b आता है, 1 upon ax plus b, that means it's a linear quantity with a coefficient of x as a, then this is 1 upon a log of, again the same thing, you have to divide by the coefficient of x plus b plus c. All right, now coming back to this, I is equal to 1 upon 2a, बाहर है ऐसे जैसे है वैसे लिख दिया. Now this is log of x minus a. What is the coefficient of x? x के साथ कौन है? 1 है, तो x का कोएफिशिएंट कितना बन गया? 1 बन गया. अगर 1 से डिवाइड करूं, मल्टीप्लाई करूं, कुछ भी फर्क नहीं पड़ने वाला. So I'll keep it as it is, minus log of x plus a plus c. So I is equal to, now according to the rules of logarithm, logarithm का rule कहता है log m minus log n अगर है, provided n is not equal to 0, then it is equal to log m upon n. All right, so now that means this is equal to, I is equal to 1 upon 2a log of x minus log of x minus a divided by x plus a plus c. Hence, final step, hence integration of 1 upon x square minus a square dx is equal to 1 upon 2a log of x minus a divided by x plus a plus c. This is today's second standard form. All right, let's come to the next third standard form of the day and the last standard form of the day. All right, that is third. पहले वाला हमने जो किया था, फर्स्ट वन वाज 1 अपॉन एक्स स्क्वायर प्लस ए स्क्वायर. सेकेंड वाला हमने किया 1 अपॉन एक्स स्क्वायर माइनस ए स्क्वायर. नाउ द थर्ड वन इज लेट आई इक्वल टू, नाउ 1 अपॉन ए स्क्वायर माइनस एक्स स्क्वायर. वेरी इंटरेस्टिंग एंड वेरी इंपॉर्टेंट. अगर आपको ये वाला समझ में आ गया तो ये समझने में दिक्कत नहीं होगी. दिस इज वेरी इजी टू अंडरस्टैंड. एज यूजुअल, जैसे मैंने पिछले वाले में किया था, आई एम डिवाइडिंग बाय 2a, आई एम मल्टीप्लाइंग बाय 2a, ए स्क्वायर माइनस एक्स स्क्वायर, डिवाइड बाहर किया, मल्टीप्लाई अंदर किया. नाउ दिस एडजस्टमेंट इज अगेन वेरी इंपॉर्टेंट. लुक एट द एडजस्टमेंट डन ओवर हियर, दिस स्टेप, x plus a minus x minus a. All right, now here the adjustment is again very important. The adjustment is a plus x plus a minus x, addition किया यहाँ पे, and the denominator is a plus x into a minus x. So the number of steps remains the same except towards the end. देख लो यहाँ पे, adjustment is x plus a minus x minus a, adjustment is a plus a minus x, because क्या होगा, x x cancel हो जाएगा, x minus x, और बचा क्या मेरे पास, a plus a, that is 2a. all right, now this is equal to 1 upon 2a. हम लोग separate करते हैं, this is separation, integration of a plus x upon a plus x into a minus x dx plus a minus x a plus x all right. Now just like the previous one, a plus x gets cancelled, a minus x gets, I'm so sorry, a minus x gets cancelled. Okay, so this is equal to 1 upon 2a. What remains is integration of 1 upon a minus x dx plus integration of All right, now that is equal to 1 upon 2a. 1 upon x का integration log x, so this becomes log of linear quantity है तो a minus x. Very 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 important thing, coefficient of x, you can observe here coefficient of x is 1, or rather minus 1, right? So I have to divide by minus 1 plus log of a plus x. The coefficient is 1, hence no need to do anything over here, plus c. So I have I is equal to 1 upon 2a. थोड़ा रीअरेंज कर रहा हूं, देख लो ठीक से. log of a plus x, इसका कोई प्रॉब्लम नहीं है. फॉर दिस 1 upon minus 1 is minus log of a minus x plus c. Hence I is equal to 1 upon 2a log of a plus x divided by a minus x. Again, log of m minus log of n is log of m upon n. Hence, अपने पास आ रहा है थर्ड स्टैंडर्ड फॉर्म 1 upon a square minus x square dx. That is equal to 1 upon 2a log of a plus x upon a minus x plus c. This is today's third and last standard form. Right? Do not worry, we are going to meet in the next class. I am keeping the class short so that आप थोड़े थोड़े जैसे मैं देते जा रहा हूँ उसको पक्का कर लो, स्टेप बाय स्टेप सबको पक्का कर लो इसको. Right? Repeat and revise this continuously so that you become thorough with these proofs. Okay. Now, in the next class, we are going to discuss about the next three sets. इसी तरीके से next three sets होंगे 1 upon root of x square plus a square, 1 upon root of x square minus a square, and 1 upon root of a square minus x square. Of course, वहाँ पे मैं एक extra भी लेने वाला हूँ. But otherwise, these are three sets of three forms. Okay. That's it for today, for this class. Right? I'll see you in the next class for the next set of three standard forms. Okay. Bye bye till then. See you.